Hello. In this video I will show you how to do crashing of a small project. We have the project network, and we have in this table here we have the normal times in the first column, crash times in the second column, and then the cost of crashing per day for each activity in the third column. The task ahead is to decide which activities must be crashed to reduce project time 1 day, and what activities must be crashed to reduce project time 2 days. To start, we will use the normal times, which I have indicated inside each node. Let's work the network forward. 6 gets carried over, plus 10 is 16. 5 gets carried over, plus 4 is 9. 9 gets carried over, plus 9 is 18. Now that we're working forward, we pick the highest early finish time to make that the early start time for activity F. So I will pick 18 plus 2 is 20. Now I work it backwards. The 20 becomes the latest finish time for activity F and also for the project, of course. 20 minus 2 is 18. 18 minus 9 is 9. 18 minus 10 is 8. 9 gets here, minus 4 is 5. 8 comes here, minus 6 is 2. And 5 comes here, minus 5 is 0. So we have identified the critical path to be, because of the slacks, of course, slack here, I will use red color. Slack here is 0. I'm sorry, not there. Slack here is 0. Because 5 minus 5 is 0, or 0 minus 0 is 0. Slack here is 0, here is 0, and here is 0. This slack right here for activity A is 2, and for this one is also 2. So the critical path is C, D, E, F. So I will mark here C, D, E, and F. These are the critical activities. Even though activity B has the least cost associated with it, when I want to reduce the actual project time, I should not crash activity B, because if I do that, it's not going to reduce the project time. You must remember that the project time is driven by the critical path, so only the critical path activities must be crashed. For example, let me just show you. If I were to reduce activity B by 1 day, because you might think that it has the least cost of crashing associated with it. But if I crash activity B right here, instead of 10, if I were to write here 9, meaning that I have I plan to crash it 1 day, then when I'm working at this point, 6 plus 9 is 15. So this becomes 15, but when I work over here for activity F, still I must choose the highest number, which is 18. So really I haven't reduced the project times. The project time 18 plus 2 will still remain to be 20. So that's the reason why we need to crash only critical activities. Having said that, looking at the list of critical activities that we have, C, D, E, and F, you can examine and see C is the least cost. So the answer to question 1 is we need to crash activity C. Now what about crashing it crashing the project for 2 days. Well, when we crash activity C, then we know this critical path right here, instead of it being 20 days, it becomes 19 days. But the top path will not change. It will still remain the same. So the critical path will become, instead of 20 days, it'll become 19 days. So when I come to the table, I can see that by crashing activity C 1 day, I'm already at 4. I will get it done in 4 days, but it cannot be crashed anymore because its crash time is 4 days. So C comes out of the picture. So the only remaining activities that that I will have are going to be D, E, and F. And of all of those, E is the least cost, and therefore to reduce the project time for 2 days, you need to crash activity C, of course, which we did already in order to reduce the project time down to 19. But when you want to take the project time down to 18, you must crash activity E. This will mean that C will be crashed at a cost of 300, and E will be crashed down at a cost of 500. So the total cost of crashing will be 800. Of course, the actual normal time of getting the project done in normal times, whatever cost there is involved there, will remain intact. But the 800 is the additional cost of crashing it beyond its normal time, the project beyond its normal time, from 20 days to 18 days. I hope you found this helpful. Thank you.